Hello guys, welcome once more to another video in our YouTube channel. So as you can see in this video, we are going to be looking at the entrance examination into the College of Technology BUEA 2021 Mathematics paper 2, question number 4. So I'm just going to display the question. We read the question together and then I guide you through with the various hints and the solutions to get the solution to the problem. Alright, so the question reads: in order to monitor buses of the Musango Express Agency, a garage manager decides the number of breakdown of the buses using the sequence U of n, defined by U of n plus 1 equal to 1.05 U of n plus 4. Okay. Given that U of 0 is equal to 40 is the number of breakdown by the buses of this agency from the 1st of January 2000, and that for every n that belongs to the set of natural numbers, U of n is the number of breakdown of the buses as from the 1st of January of the year 2000 plus n. Alright, now Roman 1, calculate U1 and U2. B, given that for all natural numbers n, V of n is equal to U of n plus 80, Roman 1 of question B, express V of n plus 1 in terms of V of n, hence deduce the nature of V of n. Roman 2, express V of n in terms of n and deduce that U of n is equal to 120 times 1.05 to the power n minus 80. And finally, question C, find the number of breakdowns that will be registered by the 1st of January 2020. Alright, so the objective of the question, first of all, we have an express agency, and then you have a garage manager that decides the number of breakdown of the buses, and he uses this sequence U of n plus 1 is equal to 1.05 times U of n plus 4. Now, on the 1st of January in the year 2000, the number of breakdowns was given by 40. And then now, on the 1st of January of the year 2000 plus n, the number of breakdowns is given by U of n. So U of n is the number of breakdowns from the 1st of January of the year 2000 and n. That's why U of 0 is the number of breakdowns from the 1st of January of the year 2000, because when you fit n here to be 0, you just get the year 2000. So U of 0 is the number of breakdowns from the 1st of January of the buses from on that year, that's 1st of January 2000. Alright, now A is asking us to calculate U1 and U2. So U1 here just represents when n is equal to 1, right? So the year is going to be 2000 plus 1, which is 2001. So U1 is just the number of breakdowns of the buses as from the 1st of January 2001, and then U2 is the number of breakdowns of the buses as from the 1st of January 2002. Alright, so since we have information about U of n plus 1 in terms of U of n, we also have U of 0, so we are going to proceed as follows. Now our U of n plus 1 is 1.05 times U of n plus 4, and our U0 is 40. That's the given information that was given. Now how are we going to find U1 and U2? Our U1, it means that you just let n to be 0, you get U1 on the left hand side. On the right hand side, you get what? 1.05 U0 plus 4. That is it. Now to get U2, you let n to be 1, you get U2 to be equal to 1.05 U1 plus 4. Alright, so to get U2, you first of all need to get the value of U1. So since to get U1 you need the value of U0, and U0 was given, U0 is 40. It means that our U1 is equal to 1.05 times 40 plus 4, and then our U2 is 1.05 times U1 plus 4. So we are going to get the value of U1 and then we substitute back into the second equation to get the value of U2. Alright, so clearly when you do this, you get 1.05 times 40 is 42, then plus 4 gives us 46. Then our U2, you have 1.05 times U1, which is 46 plus 4. Doing that, you get an approximate value of 52.3. But now you cannot actually have 52.3 breakdowns. You see, the breakdowns is a natural number, so we need to take the greatest common integer, because the number of breakdowns of the buses cannot be in point form. So we have that our u of n belongs to the set of natural numbers. It is a natural sequence. So from there, it means that all the terms in u of n, that is u of 1, u of 0, u of 1, u of 2, right up till u of n, should also belong to what, the set of natural numbers. So it means that our u of 2 cannot be in point form, so we need to take the greatest integer. So it means that our u of 2 is going to give us 52, where we take the greatest common integer of 52.3. We take the greatest integer that is less than 52.3. So our u of 2 is going to give us 52. Now remember that u of 2 is what? Is the number of breakdowns of the buses from the 1st of January to from the 1st of January of the year 2002. So there were 52 breakdowns. U of 1 is from the 1st of January 2001. There were 46 breakdowns. All right, so we are done with option question A of the question 4. Let us proceed to the next question, which is B, Roman 1. All right, so here is the information that was displayed. Now B says that we have a sequence, a new sequence, V of n, which is u of n plus 80. Now Roman 1 is asking us to express V of n plus 1 in terms of V of n, and then we deduce the nature of the sequence V of n. Alright, so our V of n is given by u of n plus 80. What is V of n plus 1? Is u of n plus 1 plus 80. But we have information about u of n plus 1. Our u of n plus 1 is 1.05 u of n plus 40. So this is it in blue. So you have 1.05 u of n plus 4, sorry, then plus our 80. Alright, so with that, we can add 4 to 80, we get 84, and then we add it to 1.05 times u of n. But the objective is to find v of n plus 1 in terms of v of n. Here, our v of n plus 1 is in terms of u of n. So we now get back to the relationship between our v of n and our u of n. We get the value of u of n in terms of v of n, and then we fit. Alright, so from here we get that our u of n is equal to v of n minus 80. So it means v of n plus 1 is equal to 1.05 into v of n minus 80, then plus 84. Now if we add, if you multiply 1.05 times v of n, we get 1.05 v of n. If we take 1.05 times 80, we get 84, but now there is a negative sign, so negative 84, then plus this 84. Now negative 84 plus 84 is 0, so what do we see? We see that v of n plus 1 is equal to 1.05 times v of n. So we have succeeded in expressing v of n plus 1 in terms of v of n. Now we have to deduce the nature of v of n. Clearly we see that what, if we take the ratio between v of n plus 1 and v of n, we get a constant. So clearly we can conclude that the sequence v of n is a geometric sequence. This constant is referred to as a common ratio of the geometric sequence v of n. Alright, Roman 2, express v of n in terms of n and deduce that u of n is equal to this quantity in terms of n. Alright, so since we have identified that v of n is a geometric sequence, we can look for the first term. We already have the common ratio is a ratio between the n plus 1 term and the n term, or the ratio between any two consecutive terms is 1.05. Alright, so our v of n plus 1 is equal to 1.05 times v of n, and we have identified that v of n is what, a geometric sequence. So it means our v of n is equal to v0 times the common ratio raised to the power n. Remember that it is not to the power n minus 1 because we are beginning from 0. If we are beginning from 1, if you add the v1 here, then the common ratio will be raised to the power n minus 1. So since I'm beginning from 0, it means that I have added one term to the n minus 1. So the number of terms is now n minus 1, then plus one term that I've added to give me n. Alright, so my vn is equal to v0 times the common ratio, which is vn plus 1 divided by vn, all that raised to the power n. So it means that we can now get our v0, since we have vn plus 1 divided by vn. Our v0 is just equal to what, u0 plus 80. but we have information about U0. Our U0 is 40, so it means our V0 is 40 plus 80, so our V0 is what? 120. So we come back here and we refit all the missing terms, and we get our Vn to be V0, which is 120, and then Vn plus 1 divided by Vn is 1.05. Then I raise it to the power n. So I have gotten, I've expressed V of n in terms of n. Now I need to deduce that U of n is equal to 120 times 1.05 to the power n minus 80. Alright, so to deduce this, I'm going to use a relationship between V of n and U of n. Our V of n is equal to U of n plus 80. What does it mean? It means that our U of n is equal to V of n minus 80. But what is V of n? Is this quantity. So we can deduce automatically that our U of n is equal to 120 times 1.05 to the power n minus 80, which is what was required to prove. Alright, and finally, question C. Find a number of breakdowns that will be registered by the 1st of January 2000. Now, this U of n here indicates what? Indicates the number of breakdowns of the buses as from the 1st of January of the year 2000 plus n. So we have our U of n to be equal to 120 times 1.05 to the power n minus 80. Now, we need to find the number of breakdowns that will be registered by the 1st of January 2020. It therefore means that what? Since U of n indicates the number of breakdowns of the buses from the 1st of January of the year 2000 plus n, it means that to get the number of breakdowns of the buses registered by the 1st of January 2020, it means that our 2000 plus n will give us what? 2020. So clearly n is just 20, because 2000 plus 20 gives us 2020. So here we are required to find U of 20. So our U of 20 is equal to 120 times 1.05 to the power 20 minus 80. Alright, like I said, our U1, when we're calculating, I explained that U1 is the number of breakdowns of the buses from the 1st of January of the year 2000 plus 1, right? Because our n is equal to 1 to get U1. When n is 2, we get U2. When n is 3, we get U3. So when n is 20, we get U20. And the year is going to give us 2000 plus 20, which is 2020. So it means U20 is the number of breakdowns of the buses from the 1st of January of the year 2020, as UN is the number of breakdowns of the buses as from the 1st of January of the year 2000 plus n. Alright, so simplifying this using your calculator, you get 238.3. But like I said, that's when you do this, you get approximately 238.3. But like I said, you cannot have breakdowns in point form. You see, you cannot have a breakdown in point form. You cannot break down 0.5 times. So you need to take the greatest common integer. So it means our U20 gives us 238, meaning greatest common integer of 238.3 is the greatest integer that is less than 238.3, and the biggest integer that is less than 238.3 is what? 238. So that comes to the end of the video for this question. For those of you who have not yet subscribed to the channel, please endeavor to subscribe to the channel. Also turn on your notifications so that when subsequent videos are going to be uploaded, you're going to be notified. Alright, thank you and see you in the next video.